Hey friends, my name is E and welcome to a new video for IGCSE Geography. And today we have a video on 2.1 Earthquakes and Volcanoes. And here's the topic, which is Earthquakes and Volcanoes as well. So here are the specifications from the website, right here. And in this video we have two case studies, which the first one is an earthquake, which will look at the Haiti Earthquake. And number two is a volcano, which will look at the Montserrat Volcano. Starting with earthquakes. So here are some key terms for earthquakes. So as we know, earthquake is a sudden movement of the Earth's crust, and the focus is a position within the Earth where an earthquake occurs. So here we have a diagram right here. We have the hypocenter or the focus, which is right here, which this point is where the earthquake occurs, right? And directly above this point, it's called the epicenter. So epicenter is a point on the Earth's surface directly above the focus of an earthquake, or the hypocenter of an earthquake. And the subduction zone is the area where one tectonic plate slides beneath another, as subduction means like sliding beneath another. So here are some notes. So earthquakes occur after a buildup of pressure causes rocks and other materials to give way. And they are associated with all types of plate boundary, where there are converging, diverging, converging, which we'll look into it in the next slide. And deep focus earthquakes are associated with subduction zones, where a more dense plate, usually the oceanic plate because it's so much more heavier and denser, slides beneath a less dense plate, for example, a continental plate. And shallow focus earthquakes are generally located along constructive boundaries, which will look into what these means in a few slides. And now we'll look at Richter scale and the Mercalli scale. So the Richter scale, it was developed by Charles Richter right here, and it's a scale that measures the magnitude or the strength of an earthquake using a seismometer. And it's generally between 2.0 to 10.0. And note that it's a logarithmic scale. And the other scale is the Mercalli scale. And the Mercalli scale describes the intensity of an earthquake based on its observed effects. And it's measured from the strength of this one right here, 1, or like I, to XII, which means it's 12, which is total destruction. So the Mercalli scale depends on the observed effect. So if you're, let's say, in the desert, it's quite hard to look at the effects. So like the Mercalli scale wouldn't be very effective in certain areas of the world. And now we'll look at plate tectonics. So here we have the structure of the Earth, and it's made out of four main layers. The inner core right here, the outer core, the mantle, and the crust. And here we have more notes on plate tectonics. The solid crust, which is the most outer layer, is cracked into tectonic plates, and is split into continental, where continents are on it, continental, and oceanic plates. And the main plates are the Pacific plate, Indo-Australian, Antarctica, North American, South American, African, and the Eurasian plates. And the movement of tectonic plates causes tectonic activities and new landforms. And new landforms are formed when it's a divergent boundary, which we'll look more into it later, but here's just a quick explanation. So let's say you have these two plates, right? Let's say if they're moving away from one another, it's diverging. This means that the magma the lava, or we call it magma from the bottom, will rise up, it'll rise up, which when it hits the ocean, it will cool down, forming new land. So this is where it forms new landform, right here. Moving on, we have tectonic shift. So as we mentioned before, we have four main types of plate boundary. We have the constructive boundary, which is a divergent plate boundary. So this is when two plates are moving apart from each other, hence divergent, right? And if this happens in the ocean, new oceanic crust is formed, and this creates a mid-ocean ridge. For example, the mid-Atlantic ridge, which you can see on the map. And here we can see here the divergent plate boundary, where two plates are moving away from each other, causing this rise of magma, where the magma can then cool down to become a lava, and basically cools down to become a new landform. And then we have these two convergent plate boundaries. It could either be destructive boundary or collision boundary depending on what plates are moving or sliding against each other. So starting with destructive boundary, it's when a dense oceanic plate moves towards a less dense continental plate and sinks, and it is subducted beneath it. So as you saw in the previous slide, there's a subduction zone right here. So it subducts, the oceanic plate subducts below the continental plate, this subduction zone. And deep sea trenches and island arcs are formed in this destructive boundary. And then we also have collision boundary where two continental plates collide, or like two oceanic plates, and they both are folded up into fold mountains. For example, the Indian plate colliding with the European plate to form the Himalayas mountains, the mountain range. And then we also have the conservative boundary or the transform plate boundary right here. It's when two plates, like let's say continental and continental, slip sideways past each other, but land is neither destroyed nor created. So as you can see here, one plate's moving downwards and the other plate's moving upwards. It's not destroying any land or it's not creating any land. It's just like sliding past each other, forming fault lines. Like here, like the San Andreas fault. And here we have some notes on earthquake hazards. So earthquake is associated with primary and secondary hazard, where primary hazards is just basically hazards that are directly caused by earthquakes. For example, ground shaking and ground splitting. Secondary hazards are hazards that are caused by primary hazards. So for example, because the ground shakes and the ground splits, this causes the currents, like big waves to be formed in the ocean, which will cause tsunami. So basically these hazards cause this hazard right here. And then we have damage from earthquake. So the extent of earthquake damage depends on factors such as the nature of the earthquake itself as well as social reasons. Because social reasons include like how many people are living in that area at the exact time. And if there's lots of people living in that area, that means that the damage from the earthquake will be huge. And here are some factors, for example, the strength of the earthquake, the distance of the nearby town from the epicenter or the focus, the population density as I mentioned, the type of rocks and settlements in the town, whether it's built on hard rock or soft rock or different like clays or any type of rocks, the extent of damage from the secondary hazards and what secondary hazards are there in the caused by the earthquake's primary hazards, as well as the communication links available, where help can then arrive at the place or not. And here we have some notes on reducing impacts from earthquakes. So we have some solutions or reducing impacts. So number one, we have build more seismic or earthquake-proof buildings. We can also educate people on safety from earthquakes. And you can also develop better forecasting technology to predict earthquakes. For example, by measuring crustal movement and noting strange animals' behavior. And we can also, like linking from education, educate people. We can avoid living in certain areas, and we can build safe houses with solid foundation. And then we have a case study on an earthquake, which will look at the Haiti earthquake in 2010. So Haiti is a Caribbean country located in the Western Hemisphere near the equator. So here we have the map right here. We have the America, and Haiti is right here. And Haiti lies in the border between the Caribbean plate and the North American plate, and it's a convergent boundary. And here's some stats on the population and land area. And this earthquake is quite deadly, and it happened in 2010 on this exact date at 4:35 PM local time. And it measured a magnitude of 7 on the moment magnitude scale, right here, the Richter scale. And the epicenter of the earthquake was 56 kilometers from Haiti's capital city, Port-au-Prince. So here are some notes on the location of Haiti, as I mentioned, and the different notes on the plate boundaries movement. So here are some impacts from the earthquake. We have economic impact, an estimated of around $8 billion in damage, which is a lot, and this was greater than Haiti's annual GDP. And from 2010 to 2015, Haiti suffered an average GDP loss of up to 12%, which is very significant. And also infrastructures were destroyed, which means that people won't have, like, let's say, electricity or clean water supply. And then we have environmental impacts. These are quite straightforward because it's what you can see from the earthquake or what you can imagine. For example, rubble from collapsed buildings causes a build-up of road links and block them. And this means that crucial aids were slow to arrive as the port is destroyed, and sea level in the local area changed, and trees were uprooted, causing soil erosion's problem. And linking the economic impact of infrastructures were destroyed, we can look at the social impacts. 2 million people didn't have any food and water, and disease broke out, and there are around 600,000 cases of cholera due to contaminated water. And then here's some cases. Oh, as I mentioned, it's like repeated, but yeah. And here are some responses from the for the earthquake, or like to the earthquake. The World Vision International is a humanitarian aid organization, and they have worked to improve the lives of children in Haiti for the last 30 years, or for 30 years. And here is what they did. And the Haiti Earthquake Emergency Response Team assisted 2 billion people during the first 90 days following the earthquake, which is very crucial because most people needed help in the first few weeks. And the USA donated around $100 million in aid, and the EU donated around $330 million in aid, and there are around 23 major charities raising $1.1 billion for relief efforts. However, this is quite important. It is said that only 2% of the relief money, which are all of these money, are used was released for aid due to corruption in Haiti. So people are blaming Haiti's government for the slow recovery of the earthquake, as there was said to be corruption, as only 2% of the relief money was released. And countries like the USA sent engineers to fix the port, and relief camps were set up, and the neighboring countries accepted some refugees and provided support. And temporary schools were created after 6 months, and new teachers trainees were trained. And eventually, water and sanitation was supplied for 1.7 million people. And moving on, we have volcanoes, which is the second part of the topic. So here we have some notes. We have some key terms. We have volcano, which is a cone-shaped mountain formed by material erupted from below the Earth's surface. And then we have ash, which is very fine-grained volcanic material. And then we have the hot spot, which is a small area of the Earth where magma rises through a continental or oceanic plate, as mentioned. And here's a key difference between magma and lava. Magma is where it's like molten rock within the Earth, and when magma reaches the surface, it is called lava. So here we have like a composite volcano, or like a volcano. Here we have the magma chamber. We call it the magma chamber right here, where it's all like molten rock. It's called magma, right? Once the magma rises to the top and it cools down, like it erupts, boom, 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 and it cools down, or like just it reaches on the top, it's called lava because it cools down on the surface. And here are some notes. As mentioned just now, a volcano is an opening on the Earth's crust where magma and ash are erupted onto the land, and they are found at the plate boundaries, for example at constructive or destructive plate margins. And there are chains of volcanoes located at an isolated hotspot. And here we have the 2 types of volcanoes that we'll focus on in IGCSE geography. We have shield volcano and cone volcano, and they are both quite different. So shield volcano is a gentle, low-angled volcano formed by runny basaltic lava. For example, this volcano in Hawaii. And the lava is capable of flowing long distances before cooling. The opposite of that, or like the other volcano, is called the cone volcano, and it's a steep volcano formed from sticky acidic lava, ash, and cinders. So shield volcano is very gently sloping. Let me just show it out. Shield and cone volcano. So shield volcano has a very wide base, like this. Imagine this is like a volcano, like the magma chamber, like this. Whereas cone is very steep. And this is all due to the composition of the magma, or the rock within the magma chamber. And here are some notes on shield volcano and cone volcanoes. So shield volcanoes are found in hotspots and in constructive plate margins right here. It's very important. And the lava from shield volcanoes are darker in color as the magma is low in silica content. So it has a lower viscosity. So it's quite important. It has a lower viscosity, right? That means it can flow much easier. So it can reach to a further base, like flow, flow, flow. The opposite of that, where cone volcano or stratovolcano, it has a high silica content. This means that the lava or the magma is much more viscous. Therefore, this means that the lava can travel far distances, so it will just like become taller and taller. And you can have a read the rest of the notes. And here's like a photo to compare the sheet volcano and composite volcano. And we'll now look at the structure of volcanoes. So here we have some key terms which I talked about some in the previous slides. So we have the chamber or the magma chamber, where it's basically down here, where it holds the reservoir for magma. So we have a crater, which is basically a depression or like a hole, so to say, at the top of a volcano, right here. And then we have a vent, which is a channel through which volcanic material is ejected. And then here we have the difference between an active volcano, dormant volcano, and extinct volcano. So active is where the volcano is still erupting or shows sign of erupting. Dormant is where the volcano hasn't erupted for a very long time, but doesn't mean that it won't erupt again. Whereas extinct volcano just means that the volcano has not shown signs of volcanic activity in historic times. And here are examples of the different active, dormant, and extinct volcano. And here we have volcanic hazards, so we have different volcanic strength. The strength of a volcano is measured by the Volcanic Explosive Index, or VEI, and it's based on the amount of material ejected. For example, this could include the pyroclastic flow and the magma, which we'll look more into it later, as well as the height of the cloud it causes and the amount of damage it causes. And just like the Richter scale, the VEI scale is logarithmic, and it's a numerical scale between 0 to 8. And here we can see the supervolcano, an example of supervolcano. And just like the earthquake hazards, there are also different hazards associated with volcanic. There's primary, secondary, and tertiary, where just like just now, the primary hazards causes the secondary hazards, and the secondary hazards causes the tertiary hazards. And then we have the primary hazards, and we'll look more into them right now. So we have primary hazards of solid materials, for example, ash or pyroclastic flow. And these are solid materials blasted from the earth, from the volcanoes. So these are all solid materials. In a very hot cloud of hot rock and ash might stay in the atmosphere for months and might cover nearby land with ash. So here's an interesting note about the solid materials, where it can block the sun, which happened in the past. And number 2, we have mudflows or lahars, and this is when the ash from the volcano gets ejected and settles and mixes with water. And this basically causes mudflows, where it's very destructive as they can behave like floods and they can destroy houses and move them off, or like move them. And here's an example. And then we have acid rain, where sulfur dioxide SO2 is released from a volcano where magma is near the surface, and this can react with water in the atmosphere or the water vapor to cause acid rain. And moving on, we have secondary hazards. We have tsunami, just like the earthquake hazards, where basically the collapse of volcanoes or plugging of solid materials into the sea can create tsunamis which will flood an area, which here we have an example. And then we have disease, where the primary and secondary hazards might destroy houses and infrastructure. This means that there might be a lack of food and hygiene in that area, so diseases are more likely to spread in that area. And then we have opportunities from living by a volcano. So here's some notes. Despite all the hazards from living by a volcano, many people still choose to live by a volcano due to different reasons, starting with social. Number 1, people might be too poor to move or have nowhere else to live, so they are, so to say, forced to live in that same area for the longest time. Number 2, with the advancement of technology, people are willing to take the risk to move to a nearby volcano. And number 3, people might have families living by a volcano, or like they've always just grown by a volcano, and they prefer to stay together with their family by the volcano instead of moving somewhere else for different opportunities. And then we have economic reasons. So volcanic environment can be good locations for farming, as volcanic soils are very fertile, as you can see here in Indonesia, where they plant coffee beans. And there are also minerals deposited, for example silver and diamonds, near the volcanoes. And because it's very hot underground, geothermal energy can be harnessed within volcanic areas. And then here we have reducing impacts from volcanoes. Number 1, we can dig lava diversion channels to divert lava flows away from towns. And we can also spray lava flows with water, but this requires a huge water source. And number 3, we can predict volcanic activity or volcanic eruption by using monitor equipment such as seismometer, chemical sensors, and ultrasound. And lastly, here's a case study on a volcano which will look at the Soufrière Hills located in Montserrat. So Montserrat is a small island in the Caribbean, just like Haiti right here. And the island itself is named Montserrat, and the volcano that erupted in 1997 in Montserrat is called the Soufrière Hills. And the country is quite a relatively poor LEDC or less economically developed country, with an average household income of around 2,800 pounds per year. And the volcano erupted in 1997, which will look more into its impacts now. So here are the causes of the volcanic eruption. And because of where Montserrat is located, it's situated between the boundary of the Caribbean plate and the Atlantic plate. And it's a destructive plate margin, where it means that two plates collide into one another. And as we can see, because it's a Caribbean and an Atlantic, so there's a subduction zone. And in July 1995, the volcano became active after being dormant for 400 years, and it gave off clouds of ash. And this causes 50% of the island people, or the population, to evacuate to the other side or the north part of the island. And the largest settlement, Plymouth, was covered in ash and had to be abandoned. This means that Plymouth became a ghost town in Montserrat. And here are some short-term and long-term effects of this volcanic eruption. So short terms include forest fires caused by the pyroclastic flow, which is ejected from the earthquake itself, has destroyed more farmland and hospitals. And this caused around 20 deaths and over 100 people injured. And as mentioned, Plymouth, the capital of Montserrat, was covered in ash, and also, quite importantly, infrastructures and main airport were destroyed, leading to not being able to see the road due to thick ash and destroyed houses and lots of rubbles around. And here are some long-term effects. So a long time is taken to rebuild homes and vital infrastructure, for example roads and telephone links. And the ash polluted the air, which increased cardiovascular and respiratory illness, which has to do with the heart and breathing. And here are damages to wildlife. And the population, because of the volcanic eruption, fell quite a lot, as you can see here. And this decrease in population is due to emigration, which causes the effect of brain drain. And then we have more impacts. An emergency jetty was built in the north, or the safe part of the island, and some areas had no vegetation left at all, and the economy declined with more than 50% of the population being unemployed. As you can see, it's quite a big jump from 7% to 50%. And evacuees live in cramped temporary camps, which might cause the outbreak of diseases. And the eruption caused by housing shortage with a low supply in houses, and there was a 70% increase in rent as seen. And the collapse in the tourism industry, though it has gotten better due to volcano tourism, where basically the people in Montserrat, they they would bring people to tour around volcanoes, which is part of their income. And lastly, here are some responses to the volcanic eruption. So number 1, we have around 5,000 people were evacuated to the safe site or the safe zone to the north of the island from Plymouth. And the UK provided over $100 million in aid and assisted in the relief and recovery of Montserrat. And also Royal Navy sent ships to evacuate people to the nearby country, this country right here. And NGOs or non-governmental organizations, for example the International Red Cross, organized evacuation camps, which allows the people to stay in the area for some time. And the island is also promoting volcano tours in an effort to attract tourists back to Montserrat. And in 2020, Montserrat's statistics department reported visitors spent a total of $27 million in 2019. And lastly, part of the island, for example, a new urban center at Little Bay, were rebuilt and redeveloped. And that's it for this video for 2.1 Earthquakes and Volcanoes. And I hope you enjoyed this video. And if you need any more learning resources or any teaching resources, you can check out my website in the description, or you can type it out on your browser at www.MakesItEasy.com. And I hope you enjoyed this video, and I'll see you all in the next video. Here's to learning made easy.